Hello everyone and welcome to our educational session. My name is Paul Arsov and I'm the founder of the Decentralized Web project. I'm going to talk about our project in the end of this presentation, but the topic of the presentation today is building artificial general intelligence with alternatives of monopolization. The previous week event, it was about the path towards monopolization of artificial intelligence by few big tech companies. And in this presentation, we are going to talk about alternative paths to monopolization and what can be done to achieve and make this possible. The topic touches on technology and also touches on business, politics, and also a little bit of psychology as well. If you close your eyes and imagine a bustling market square, but not filled with farmers selling fresh produce, but with merchants hawking robotic arms, smart sensors, and AI software building blocks. Shoppers wander from stall to stall, mixing and matching components to build custom solutions for their farms, small businesses, and even their own homes. This is not a distant utopia, it's a plausible version of a near future world where high-end research meets mass market affordability and where everyday people can assemble advanced technologies like children snapping together toy bricks or Lego bricks. For decades, technology often took one of two routes, either expensive premium devices created by Western corporations or large-scale, lower-cost products churned out by Chinese manufacturers. Historically, these competing models coexisted in a somewhat binary landscape. The West leaned towards high-margin proprietary ecosystems. China excelled at high-volume, lower-cost manufacturing, rapidly democratizing access to hardware worldwide. But look around, that binary is dissolving fast. Chinese giants Baidu, Huawei, ByteDance stand shoulder to shoulder with their American behemoths brethren, namely Google, Microsoft, Apple, Amazon, in cutting-edge research on artificial intelligence and robotics. Meanwhile, Western startups are seeking ways to produce hardware at scale without prohibitive price tags. On all sides, there's a quiet revolution brewing. Modular, customizable technologies that enable a global explosion of innovation, whether you're in Nairobi or Shenzhen or in Kansas City. Imagine a Lego-style robotics marketplace. You buy a basic chassis from a company in Shenzhen, an AI vision module from a European open source collective, and cutting-edge sensors from a Silicon Valley startup. With standardized interfaces and open protocol, these pieces fit together seamlessly. No giant R&D budget required. Local entrepreneurs and engineers built tailor-made solutions small robotic shops in Ghana constructs affordable irrigation systems for small farms, and a high school club in Germany prototypes a search and rescue drone. The learning curve flattens, and the impossible becomes merely a puzzle that can be solved by mixing the right off-the-shelf modules. Thanks to online communities and market platforms, design blueprints, 3D printable parts, and software updates flow freely. This leads to what sociologists call a communal brain. New ideas pop up in one part of the world and instantly help someone else in a continent away. As robotics and AI components become more accessible, education pivots to teaching problem solving, assembly, and customization, skills that keep pace with automation. Societies that invest in such learning see an economic boom as tinkerers create micro-industries around novel applications. The old notion that only the West builds fancy tech while China focuses on mass production no longer holds. Cutting-edge AI breakthroughs like next-generation quantum chips or autonomous flying taxis will emerge from labs in Beijing or Boston or Berlin or Bengaluru alike. Competition thus intensifies in multiple dimensions. Landmark discoveries in areas like neuromorphic computing, advanced AI architectures, or humanoid robotics could come from anywhere. Generous research grants, new university programs, and global moonshot projects bolster diverse innovation hubs. Demand remains enormous for affordable consumer robotics, drones, and household devices, particularly in rapidly developing regions. Chinese manufacturers still hold an edge on scaling production, but Western and other Asian companies rise to match cost efficiencies. Countries like Japan might become leaders in emotional companion robots for elder care. Europe could pioneer strict privacy-focused AI frameworks. India may specialize in data automation and affordable healthcare robots. US may lean into high-stakes enterprise and defense solutions. This modular patchwork fosters diversity in how AI and robotics integrate into daily life. One of the most startling changes in this imaginable future is the democratized supply chain. Rather than massive centralized factories producing every component, specialized microfactories pop up around the globe. Thanks to 3D printing and efficient logistics, final assembly can happen closer to the end user. Localized assembly means fewer disruptions from global geopolitical tensions or shipping crisis. If one supplier falters, a nearby alternative can step up. Thousands of smaller firms can cater to unique needs. agricultural robotics in one region, marine drones in another, offering local solutions at competitive prices. Want a sensor that measures the pH of your greenhouse soil? Download the design from an open source platform, tweak it to your specific climate, and either 3D print or order parts from a local supplier. What does this mean for everyday life? The first thing is localized entrepreneurship. Instead of just creating another app or a small town entrepreneur may assemble a bespoke farming robot tailored to the local terrain, empowering community agriculture and reducing reliance on large corporate suppliers. The second thing is collaborative governance. Governments partner with educational institutions and private companies to create innovation hubs that teach modular design, coding, and robot assembly. Skilled trades become more tech-focused. Electricians leap to wire up AI sensors. Mechanics adapt to servicing robot limbs, and so on. The third thing is equitable access to technology. Lower cost modules mean that people can afford to integrate advanced AI into their daily routines, like safety monitoring systems for the elderly or personalized tutoring robots for remote learning. Society benefits at all levels, bridging some of the digital divide. Continued regulatory hurdles where convenience spread, so can risk. Fragmented supply chains and open source hardware may introduce security vulnerabilities, prompting calls for standardization and certification. Striking a balance between innovation and safety becomes a global challenge. No future is without pitfalls. Geopolitical rivalries could still fragment supply chains, or over-automation may strain the job market. But the silver lining in a world where no single power monopolizes progress, people worldwide increasingly contribute to and benefit from a more open, modular approach to AI and robotics. In this hypothetical scenario, which unites Shenzhen, Silicon Valley, Nairobi, Berlin, and etc. in a shared ecosystem of creators, engineers, and entrepreneurs. Each draws on a vast library of modular tools, pushing boundaries in agriculture, healthcare, space exploration, environmental conservation, you name it. Tech is no longer just a top-down affair, but communal resource, akin to how the internet once revolutionized global connectivity. Ultimately, our collective future may be shaped not by which country can outdo the other in premium features or volume manufacturing, but by the synergy in both approaches, spurred by affordable building blocks, boundary-pushing research, and a world of tinkerers taking innovation in their own two hands. The question then becomes, how do we harness this new reality for the greatest possible good, while ensuring it remains safe, equitable, and sustainable for all. If we answer these questions together, then the bustling market square, where robotics, AI, and individual creativity converge, may indeed become our vibrant, collaborative tomorrow. And with this said, I'm ending this presentation, and I'm coming back to the beginning of this presentation when I told you that my name is Paul Arsov and I'm the founder of the Decentralized Web project. I like to tell you about the Decentralized Web project and several other projects that we're working on. The Decentralized Web project is building decentralized communication and advertising platform. It is monetized through advertising, and it has its own blockchain instance which rewards users for joining the platform and for viewing advertising and for inviting other people to join platforms. The name and the URL of this project is decentralizedweb.org. Decentralized and web, these are two words and they're typed all together. Decentralized web. Then there is dot and it ends with org. And with this said, I'm ending talking about Decentralized Web project, and I'd like to tell you about our 3D NFT marketplace and collection of NFTs. With 3D objects which are collected and presented as non-fungible tokens in our marketplace, we need a special software which can read the 3D object file, then displays this 3D object file, and then can do some manipulation of this 3D object. The name and the URL of this website of this project is 3dnft.decentralizedweb.org. 3dnft is typed in a way of the number 3 followed by the letter D followed by 3 other letters NFT, and altogether this is 3dnft. Then there is dot, then there are two words typed all together, decentralized and web. Then there is dot and it ends with org. Once again, 3dnft.decentralizedweb.org. From the very beginning of our 3dnft project, we decided to build our own 3D software engine, and instead of using standard software engines like the game engines most often used by 3D software creators, and namely there are two very popular game engines, Unity or Unreal. But we did build our own 3D software engine, and what it does it reads the 3D object, then it opens a window on a computer screen, it displays the 3D object, and then it starts animating this 3D object in a way of moving it in a random fashion around the window it opened. But in addition to this initial and basic capabilities, the 3D software engine has multiple additional capabilities. The first capability of our 3D software engine is the capability of speaking. The 3D NFTs can speak in one of three different voices, either in a male voice or female voice, or in a whisper kind of a voice. In addition to the three different voices, there are three different flavors of voices. A voice can be spoken in a fast speed manner, or in a slow speed manner, or in a normal speed manner. So if we take a male voice and it is spoken in a slow speed manner, then this voice can come as the voice of a very masculine person or the voice of an old person. And if we take a female voice and it is spoken in a fast speed manner, then this voice can come as the voice of a funny person or the voice of a little girl. The next additional and important capability of our 3D NFTs is the capability of voice recognition. For example, if we are having a 3D NFT moving in a random fashion around the window, being animated, we can then issue our very first voice command to the 3D NFT to stop moving. And then the 3D NFT is going to stand still and stop moving. We can issue following voice commands to the 3D NFT to move left, move right, move up, move down, zoom in, zoom out, rotate. And then the 3D NFT is going to fulfill each one of these separate voice commands. The next additional important capability of our 3D software engine is the capability of the 3D NFTs having a basic artificial intelligence. Wow, really wow. The 3D NFTs can you can ask the 3D NFT what is your name, and then the 3D NFT is going to reply with their name. You can ask the 3D NFT who are you, and then the 3D NFT is going to reply in few sentences on who they are. You can ask the 3D NFT to describe something. For example, describe Web3 or describe decentralization or describe Russia. And then the 3D NFT is going to describe in few sentences about Web3 or decentralization or the country called Russia. The last additional but not least important capability is the capability of the 3D NFTs being displayed in a way of stereoscopics. What stereoscopics means is that part of the 3D NFT is going to be displayed in red or reddish colors, and another part of the 3D NFT is going to be displayed in blue, cyan or bluish colors. And then you can come to our website. Once again, the name and the URL is 3dnft.decentralizedweb.org, and on the top of the main page and every other page you can see the link to accessories. When you click on this link, you're going to see that we are offering special glasses, and you can order one pair, and when you receive these glasses you're going to see that one lens of these glasses is red and the other lens of these glasses is blue cyan. Then you can put these glasses on. You can request displaying the 3D NFTs in a way of stereoscopics, and then you are going to see the 3D NFT as coming out of the flat two-dimensional computer screen, and you're going to see it in real 3 dimensions. With this set, I'm ending talking about our 3D software engine. I'd like to tell you about our 3D NFT marketplace. In our 3D NFT marketplace, we have our own blockchain instance. It runs Ethereum software, and it is the same software which runs on Ethereum mainnet. It runs on Binance Smart Chain. It runs on Polygon Matic Chain. It runs on Avalanche Alex Chain, and it runs on many other famous or not so famous blockchains. In this way, by having our own blockchain instance, we do not charge our users for deployments of the smart contracts for the non-fungible tokens, and we do not charge gas fees our users for transactions of transfer of ownership from one user to another user. In addition to this, we allow buying and selling in multiple crypto coins, and currently the choices include Solana Sol, Polygon Matic, Avalanche Avax, and Qcoin, which is big centralized crypto exchange. They have a coin called KCS. But in addition to buying and selling with crypto, we have a second parallel and independent way of buying and selling of 3D NFTs done entirely in fiat currency. So let's say you are a user, you come to our 3D NFT marketplace, you click on the composite image of the first collection, you see all of the 3D NFTs displayed, and then you click on one that you like. You're going to be presented with a video which shows the 3D NFT as it is moving, and then you're going to have a drop-down menu which asks you to select between 4 different coins and a fifth choice of buying with fiat currency. And when you select buying with fiat currency, then you're going to be presented with the next screen, which is going to ask you to put the number of your debit or credit card, expiration date, CVC, and when you click on the button to complete the transaction, what is going to happen is there's going to be a transfer and conversion of the payment from your national fiat currency to US dollars, and it is going to be deposited in our bank account. Then we're going to follow with transaction and transfer of the initial ownership from the 3D NFT marketplace to you, and now we will become user of this 3D NFT. You can play for a while with this 3D NFT, and then you can decide to put it for sale. You decide on the price you want to put to sell this 3D NFT. And let's say there's a second user. They come to our 3D NFT marketplace. They browse through the 3D NFTs, and they like in particular the 3D NFT that you put for sale. The second user is going to go through the same step between choosing to pay with crypto or fiat currency. Let's say they select payment with fiat currency. Then on the next screen they put the number of their debit or credit card, CVC, expiration date, and when they click to complete the transaction, there's going to be a transfer and conversion from the national fiat currency of the second user, which could be different from your national fiat currency, and there is going to be a conversion from the national fiat currency of the second user to US dollars, and it is going to be, the transfer is going to be deposited in our bank account. Then we're going to follow it a transaction and transfer of ownership from you to the second user, and now the second user becomes owner of this 3D NFT. And we're going to follow this with a third action and a transfer and conversion from US dollars to your national fiat currency, and this transfer is going to be deposited in your bank account in your national fiat currency. With this said, I'm ending talking about this project. I'd like to mention a third project that we work on, and this third project is building products for charging of electric vehicles. The products that we're building are outfitted with high voltage and high current switch. They're outfitted with wireless network connection, Wi-Fi connection. They're outfitted also with current sensor to measure the exact current and power which was consumed by the electric vehicle. And finally, it is the products contain also a near field communication reader, which can read your debit or credit card or near field communication card or near field communication keychain token or near field communication ring, with which you can identify yourself to the charger, and the charger can turn on the power to start charging your electric vehicle, and then the charger can then bill you for the electric energy which was loaded in your electric vehicle. Currently, there's a growing number of electric vehicles used by people for driving, but at some point it may become exponential growth of electric vehicles, and currently the charging of electric vehicles, besides people charging them at their houses, people living in big like small or big cities, they would not have a house where to charge their electric vehicle, and they rely on charging stations which are modeled after gas stations for internal combustion engines. In these charging stations, there are several charging columns, and the owners of electric vehicles, they come to these locations, they connect electric cable from a charging station to their electric vehicle. They identify themselves, they start loading energy into their electric vehicle. They stay for a while at this location, and then they leave. With this said, we anticipate that with the exponential growth of electric vehicles coming and being used by people in cities or outside of the cities, it is going to become like the current charging stations are ultimately going to become insufficient to handle the growing number of these electric vehicles. With this said, we are building products which we aim to outfit in parking lots, and many of the owners of electric vehicles, they're living in residential buildings with the ground floor parking lot or multiple on the ground floors of parking lot. In addition, like the owner of electric vehicle, when they come home from work in the evening, can identify themselves to the charger. They can connect a charging cable to their electric vehicle, and they can leave their vehicle charging during the evening, night, and early morning. But owners of electric vehicles, they may be working in high-rise office buildings, and these high-rise office buildings are outfitted with ground floor parking lots or multiple underground floor parking lots as well. So the owner of electric vehicle who comes to work in the morning, they could connect a charging cable from a charger outfitted in an office building, and they can leave their vehicle to be charged during the morning, afternoon, and early evening, while the owner of this electric vehicle is in the office working. With this set, we did like write an article and put it in the website of the project. And now is the time to tell you the name and the URL of the website of this project. It is power.arstec.com. Power is the ordinary word for power, then there is dot, then there is a word which I can spell it letter by letter. It's Alpha Romeo Sierra Tom Echo Charlie Hotel. Altogether Arstec, then there is dot, and it ends with com. Once again, power.arstec.com. In addition to this article comparing gas station model versus parking lot model, we put 3 different surveys which you can fill, and these surveys are going to tell us about your needs. In particular, the first survey is asking about the hardware, the second survey about the software, and third survey about the features of charging electric vehicle charging products. With this set, I'm ending talking about this project, and I like to tell you about the fourth project that we're working on. It's about building artificial intelligence agents, and currently the project is called AI to AI. And so what the project is building is it is building a program which allows interaction between one artificial intelligence based on one large language model which has a specific gender, be it male or female, and specific pitch of voice. And this artificial intelligence entity is talking to a second artificial intelligence entity which is based on a different large language model. It has a different gender, be it male or female, and it has different pitch of voice. And the human is just an observer between interaction of the first AI entity to the second AI entity. This AI entity are talking to each other, and the user is just an observer, and the user hopefully is being entertained by this interaction. The user actually defines the parameters of this interaction. For example, it defines the user, the first AI entity. It tells the first AI entity to be very seductive, and for example, tells the second AI entity to be very angry. So in this example, the user is going to have an interaction where the first AI entity is trying to seduce the second AI entity, and the response of the second AI entity back to the first AI entity is going to be angry response, and it is going to go back and forth until you click the stop to stop this interaction. And in the end of this interaction, you can save interaction for your view, how the interaction was going. You can also share this interaction on the AI to AI website, so that other users can try what your settings were for this interaction, and they can enjoy something similar but not exactly identical to your interaction. With this said, I like to tell you the name and the URL of this project. It is AI to AI decentralizedweb.org. AI to AI is typed with the letter A followed by the letter I followed by the number 2 followed by two other letters A and I. Altogether it is AI to AI. Then there is dot, then there are two words, decentralized and web, and they are typed all together, decentralized web. Then there is dot and it ends with org. Once again, AI to AI dot decentralizedweb.org. With this said, I'm ending this presentation. Thank you for listening. Thank you for viewing. Have a nice day. Have a nice evening, and goodbye.